Hi there, this is John from RevSoft, and this presentation is an overview of group jobs in Rev Scheduler version 10.3. This applies to all platforms. Now, in some circumstances, computer jobs or tasks are run as streams where a group of jobs are executed in sequence to follow the normal business process flow. In Rev Scheduler, we refer to this as a group job. There are two components to a group job. The first is a parent job. This doesn't execute any scripts. Its only function is to control the execution of the child jobs. The parent job can have a run basis of time or trigger, so dependencies can be used to start the group process. All the jobs executing scripts in the group are referred to as child jobs, and these all have a run basis of start group. So we've got two terms for group jobs in Rev Scheduler: group parent and group child jobs. Now for the rules for the group jobs. There's 4 basic rules. First, the types of execution. Group jobs can be executed in 3 ways. Concurrently, where all the child jobs are submitted at the same time for execution. Sequentially, where all the child jobs wait for the completion of the prior or previous child job. And then mixed, where some child jobs execute concurrently and some sequentially within the same group. That's rule 1. Rule 2, a child job can be a member of as many groups as you require. Rule 3, child jobs can be executed on the local server or any network server, and all that's required is Rev Scheduler and Rev View, our free networking framework. Fourth and last rule, a group job can be single execution or multi-run with either preset times, the blue recycle, or the green recycle, which means regular intervals between executions. Okay, I got the rules. How do we define the group jobs? Okay, they're defined using sequence numbers. So in this example, sequence 10 is child job number 1, sequence 20, child job number 2, sequence 30, child job number 3. Now, the point of difference between concurrent, sequential, and mixed type of group structures is the intradependencies, dependencies on group child jobs within this structure or the execution of this job. So this is where you can define the required completion status codes as well as the sequence numbers these relate to. So we can say here that sequence 20 is dependent upon sequence 10 with a completion status of any of these. Now, concurrent type groups have no intradependencies because they're all going to go at the same time. So with the intradependencies, we can link them with if and or. So we can say here that sequence 40 is dependent upon if sequence 10 completes either of these ways, and sequence 20 and sequence 30. It's all flexible and all very, very simple to define. Okay, all good. Enough of the theory. Let's see what it looks like. In the scheduler definitions here, we're connected to an I series here. And first of all, let's check out some concurrent ones. Now, what you'll see is a group parent symbol is here. The 2 blue people mean it's going to run on this local server. The 2 blue people where one of them is basically multicolored through there means there are network jobs within that structure. Single blue type here means it's a group type job. These are time type jobs with the alarm clock. So let's see the concurrent one. Let's just have a look at that structure first. Rightio. They're all using the same jobs. Video, IBM, Child 1, 2, 3, 4. As you can see here, there are no intradependencies. Okay, let's look at the sequential one. Now what we can see different here, same jobs. So remember, a child job can be a member of as many groups as you want. It's saying here 20 will wait for sequence 10. Sequence 30 will wait for sequence 20, and sequence 40 will wait for the completion of sequence 30. Strictly sequential. Then we have the mixed setup. So what we have then here is 10 and 20 will both be submitted at the same time, which is basically concurrent. Then 30 will wait for 10 and 20 to complete in that required status. Then 40 will wait for 30. Now, all these group jobs are using exactly the same child jobs in there. There is no problem with doing it. And even better, what you'll see is all these group jobs are running at exactly the same time. 7:15, 7:15, 7:15. So they all executed at the same time. So now let's go have a look and see how they executed. Okay, off to operations, and let's see how these jobs executed. Now here they are today. They all started at exactly the same time. And what we can see there is, here's a concurrent one. All these jobs started at the same time. You'll see all the timings we have here are down to microseconds. So everything is down to millionths of seconds. These jobs do a delay of 10 seconds. So as you can see, they took a fraction over 10 seconds each time. And as you can see, they were all completing it around the same time. When we look at the sequential one, what you'll see there is because they had to wait for the prior jobs, there will be a gap between each of the executions where it's waiting for it. And then with the mixed one, what we'll see there is the first two ran fine, and we wait for the third, and then the third waits for the fourth, waits for the third. Now, if you want to see it in diagrammatic form, we also have that built in as well, where you can actually see it in diagrammatic form. This is where the job ran. Let's zoom out a little bit so we can see it a little bit clearer. And this is the basic concurrent one where everything ran at the same time. The same way, if we drill into the sequential one, we can grab the same diagrammatic type feature. And this is the same type of feature you'll see when it's actually running if we add a job watch to it, where we can show the predicted times and we can see exactly what happened. I don't know what happened there because I thought I clicked on that. Here it is here. Here's a sequential one. We're just testing the user error out there. So if, and we've got all the timings, the job numbers, everything like that. And then if we look at the mixed one, what we can see there, it's explained a little bit differently because we've got an if and. So, and they can be all exported as PDFs as well. So that's what the standard jobs look like. So now let's go back to definitions and let's check out the network jobs. So jumping back here, what we're going to do is we've now got concurrent ones. So remember, concurrent have no intradependencies. So they just all submitted at the same time. This is on AIX. The parent is running here on the I series. AIX, Windows, Red Hat, and then one on this local server. Now we created the same structures with the sequential and the mixed ones as well. So there is a sequential one where it's just waiting, even though they're running on other platforms. It doesn't matter because we have Rev Scheduler and Rev View on there. So what we're allowing people to do is to basically define and execute the jobs just as a business analyst would draw it up. Start this on this server. When this one is completed, run this on this server, and we don't care what server types they are. All right, let's go back to the operations then and have a look. Here we go. So now we've got the multicolored person there. Here's a concurrent one. Let's just have a look at that and see how that went. So what we've got is we've got the job timings here from the different servers. Don't forget AIX, Windows, Red Hat, and then iSeries. Now, what you'll see is these timings look a little bit different, and even that date looks a little bit different there. Hang on, that's yesterday. Well, that server there is on US East Coast time. These other ones are on Australian time. So we actually report the actual server time those jobs ran on that server. So we make it very, very simple to equate to. The same way I can go back to the diagrams again and I can see the explosions again within that. Now, the only difference being here is we now have the different icons for the different operating system type that's there. But it has all the dates and times that the job actually ran. This one Monday, Sunday, because Australia is a long way ahead of the US East Coast time. And the same way, if we go into the sequential one, we'll see exactly the same thing. The job ran all these different times and the timings will be there, even though they waited with those sequential intradependencies there. And the same thing if I go for the diagram there. which can also, as I said before, can be exported as a PDF. So if people want to see exactly what happened, if there, and then if we look at the mixed one, what we'll see there, let's go straight to the diagram. What we can see there is the different operating system icons or images, if, and. So we all make it very, very simple to understand what's going on there. So what we've done now is we've gone through the actual local group jobs. We've gone through the network group jobs. The only difference that happens now is if it's a multi-run job, what you do is you actually define within the job execution, which is the submission details for it, you define the multiple run details right here. This one is a green one, which means it's regular intervals between jobs, 8:15, end at 9:15 every 15 minutes, or I could have defined preset times that are not regular intervals. So that's the only difference between a standard group job and a multi-run job. You can even run your multi-run group jobs across platforms. It doesn't matter where the jobs are to be executed as long as you have REV Scheduler and REV View there. So that's how they're defined. These ones, 9:15 every 10 minutes, finish at 10:15. If we go back to operations again and see how they executed, what we'll see there is if we drill into the different times of the execution, I can see all the different multi-execution times. I didn't want that. Let's go to this one instead, and I'm on the definitions and I should be on the operations. So that's why I'm not being able to see that. So once again, we test out the user error. Here we go. So I can see the multi-run times there by clicking on that, and that will give me all the timings of when it started, when it ended, the completion status. And we've got system date and time in case you're using time zones, because we do have time zones in REV Scheduler. So you can have those defined because a lot of people now are using a server for global enterprises. So they may want to run jobs by Greenwich Mean Time, US East Coast Time, US West Coast Time, Australian Eastern Time, Vietnam time, Singapore time, anyone's time. Even time zones that don't have to be geographical. It could be a financial institution whose day starts at 2 a.m. and runs until 1:59 the next day. Is their 24-hour clock. We support all those type of things. Here are all the group jobs with the different execution numbers, 1, 2, 3. So, as we can see, here's all the multi-run executions. That's for all local ones. Let's go to our friendly networked ones, and here we are. And again, the Oracle server time is different because it's US East Coast time, so 17:17, 17:27. Every 10 minutes, we have all these details there. So group jobs, let's just wrap it up. Just wrapping it up now. The group jobs, as we know, there are 4 simple rules, and the main ones we need to know and remember: a child job can be part of as many group structures as you require. Group jobs can be executed on local servers or across network servers, and the parent jobs don't have any scripts. It's only the child jobs that have the scripts. The parent jobs are there to control the child jobs. Hopefully, I haven't confused you too much with that. If you've got any questions at all, please send them through to me or send them through to product_info@revsoft.com. Thank you very much for your time.